Imagine a computer so powerful it could process more data than there are atoms in the universe. Welcome to the revolutionary world of quantum computing, a realm where the traditional rules of computing are turned upside down. At the heart of this revolution are quantum bits, or qubits, capable of processing complex calculations at speeds that leave conventional computers in the dust. A quantum computer doesn't just execute tasks faster, it fundamentally changes how we process information. Quantum computing is not just the next step, it's a quantum leap. The concept of quantum computing has been around for decades, but recent breakthroughs have brought it into the spotlight. At the heart of this revolution are two counterintuitive principles: superposition and entanglement. Superposition allows a quantum bit or qubit to exist in multiple states at once, not just as a 1 or a 0. Entanglement, on the other hand, creates an inexplicable link between qubits, no matter the distance. From superposition to entanglement, these mind-boggling principles are the foundation of the quantum revolution. In 2019, Google claimed to achieve quantum supremacy. This was a monumental moment in the history of computing. Quantum supremacy refers to the ability of quantum devices to solve problems that classical computers practically cannot. Google's achievement was a demonstration of this, with their quantum computer outperforming the most advanced classical supercomputers. So, what does this mean? This milestone sparked a new era in computing, opening doors to unprecedented possibilities. The future is quantum, and it's closer than we think. So, what can quantum computers actually do? Imagine optimizing complex processes in record time. Picture cracking mathematical puzzles that traditional computers deem unsolvable. The possibilities are vast, and the applications are numerous. Quantum computing is set to transform a variety of sectors. In finance, it can enhance portfolio optimization. In healthcare, it may lead to breakthroughs in drug discovery. In cryptography, it could revolutionize data security. Industries like finance, healthcare, and cryptography are poised to benefit significantly. Of course, with great power comes great challenges. Quantum computing, while revolutionary, faces its own set of hurdles. The technology's sensitivity is a double-edged sword, making it incredibly powerful, but also prone to errors. Quantum systems can be easily disrupted by environmental factors, causing a phenomenon known as decoherence. Furthermore, there's the issue of error correction. Traditional methods don't work well with quantum systems, so new techniques must be developed. Overcoming these challenges is crucial for the practical integration of quantum computing into our daily lives. As research and development continue, the future of quantum computing looks promising. We're witnessing a global race to build quantum computers that are more stable, more scalable, and more revolutionary than we've ever seen. This isn't just a sprint, it's a marathon of innovation and endurance. As we push the boundaries of what's possible, we're seeing a surge in investment from companies worldwide, all vying for a piece of this groundbreaking technology. Companies around the globe are investing heavily in this groundbreaking technology.